Okay. Hello, people. And welcome to Jfokus again for you who are back, and welcome for you who are new. This is going to be great. Oh, and we have some late people coming in, of course. Hurry up. Don't worry. It's all fine. So please give a hand for Jens and Andreas for this talk on something, tax authority stuff. All right.
Okay, thanks for that great introduction. Tax authority and stuff. Yeah. That's the title. So, starting out with a question: is the Swedish Tax Authority ready for the age of AI? Well, that's a question we ask ourselves, and we'd like to ask you as well at the end of the presentation. So, starting out, me and Jens were discussing a bit about the presentation. Should we have, it's all about getting an impact. Should we start with a nice rock anthem in the background, maybe laser shows, maybe skydiving into the arena, or skydiving in here? But we quickly abolished those ideas because, fair enough, I'm not really built for skydiving anyway. So we wanted to go for a sure thing, and in the words of Mr. Franklin, there are only two things in life, or two things in this world that are certain. One is death, and the other is taxes. So that's just to start us off on our journey. So, why is AI important for a tax administration? We see that in order to meet the developments in society, requirements for efficiency improvements, the Swedish Tax Agency needs the benefits that AI can bring to the table. So we need to improve customer services, we need to make our processes, internal, external, more efficient, more automated, more digital than they are today. But we need to do this with the respect for people's privacy, rule of law, and equity. So, in the words of our Director General, we could say that AI is a matter of trust for the Swedish Tax Agency, and the trust from the society within the Swedish Tax, or their trust in the Swedish Tax Agency. So, in our AI policy, we express the ambition to strengthen society's trust within the Swedish Tax Agency. And we want to strengthen this using AI, so we want to boost and enhance this even more. And with AI, we can make the business more efficient, legally secure, and we can also develop different customer meetings and fight non-compliance and fraud. So in that way, we are using AI in the service of taxpayers, in the service of society. You can also see in the Swedish Tax Agency strategy, AI is making more and more of an impact within our strategy and within the objectives of the Swedish Tax Agency. Looking at the Swedish Tax Agency strategy, it raises issues like create effective exchanges of information. We are exchanging more and more information. We're exchanging information both with businesses and private persons, but we're also exchanging a lot of information with EU and other countries within the European Union. So the exchange of information, the amount of data, is always growing. And we need to adapt, we need to find new techniques and new methods in order to use this data. We can also see that we need to increase the degree of digitalization and automation. So we are using, once again, AI as a way, as a driver for this. And appropriate and effective automatic and manual checks. What does this mean? Well, this is actually one of the areas where Swedish tax agencies started out using AI. I think we actually have been working with AI not using the term AI, but we've been working within this area for at least 15, maybe 20 years. Starting out with statistical analysis, moving toward analytics, data mining, predictive modeling, just following the buzzwords from the years past. But what we are trying to do is in our guidance, we strive to direct our resources where we can see that the probability of error or the risk are the highest. That's where we want to put the focus, our energy, our resources. And using different techniques and method, it will help us to guide towards the highest risks or the highest probability of error. So we are working both with audit and controls, but we're also working with customer services, trying to improve our customer service, making it easy to comply and making it hard to not comply. So that's the signum of the Swedish Tax Agency. And in all of this, AI is acting as an enabler. So a lot of the objectives you can see and a lot of the text you can see in the Swedish Tax Agency strategy, you can see AI acting as a driver for this. We also have a few more direct objectives. So looking at these 3 objectives, we have one objective where we want to increase the use of AI or the available AI services that we already have in the agency. So it's about using them for new applications, new areas. And we also want to have the tools and competences. I think that we are fairly en route today already, but we want to enhance the competence within the Swedish Tax Agency in collaboration with others and ourselves to use both structured and unstructured data. We have quite a lot of data within the Swedish Tax Agency. There are quite a lot of structured data, but we are still not tapping into all of the potential within the unstructured data. And we can see that a lot of data we are still storing as images of declarations, images of incoming documents, etc. So we're still storing a lot of that data as image files, keeping them away for now from using them for digitization, automation, and AI. So that is something that we are striving to tap into even more. We also want the AI to be used more widely in the business and contribute to efficiency and increased legal security, as I said before, or legal certainty. So we have a few applications that is going in towards that area as well, supporting auditors making decisions, but also for supporting them in different tasks within the Swedish Tax Agency. I'll get to a few examples of applications later on. So looking at the policy for Swedish Tax Agency, our AI policy, we state early on that AI is our first choice. I see that a few of you are already thinking, is this an AI first strategy? Well, it's not, but we kind of like this statement. It challenges us not always to develop AI as the only solution, but we want to consider if AI is a better solution. And we think that we need to challenge ourselves if we want to change our culture within the Swedish Tax Agency, if we want to change the way we work, our processes, we need to think about, is AI a better choice for this solution? Can it help us in new ways? And in this, we can see that AI and the question or this principle actually helps us to challenge. I still think that we have a bit to go, but it helps us. As we said before, using AI and using AI in public service is a matter of trust. So we ensure sustainable AI, and as a part of the strategic work, we have a guideline towards sustainable AI, and that guideline is affecting how and what we develop within the AI area. And the general guideline is also shaping a lot of what we are doing today within Swedish Tax. We need to, as I said before, to develop AI in a way that we can respect people's privacy and the rule of law and equality. And we are following the research within this area. I saw an article, I think it was yesterday, trying to find how much papers are being produced within the AI and fairness area about ethical AI, fairness AI, etc. And it's been increasing quite a lot the last couple of 2 or 3 years. And we are following the development within ethical AI, FACCT, or Fairness, Accountability and Transparency, and we are also following the work now going on with the AI Act on the EU level. So we are trying to keep up with research within this area in order to learn more and also adapt our processes and routines within the Swedish tax. So we also want to develop in collaboration with others. So not only develop in-house, we develop in collaboration both with academia and we develop in collaboration with different vendors and other collaborations. So every problem that we have in the Swedish tax, it's not unique for the Swedish tax agency, it's not unique for the agency. It's a collaboration between other agencies and other public agents as well. So moving on to a few examples of applications of AI within the Swedish tax agency. You could see that these are actually also examples of how we try to interact. So we have, for instance, the translation service, and we have also the translation and speech to text. That was the one. So those are services where we can actually use open source pre-built or pre-trained models. So we're actually more or less packaging these pre-built open source products. And that helps us to move forward in these areas. So for instance, for speech to text, we use that for actually subtexting a lot of information campaigns, and we also use them to subtext information that we have internally within Swedish tax. The machine translation service, we use that in order to understand the needs or the demands from society. So we translate incoming communication from different languages to Swedish in order to direct documents, direct cases to the right auditor with the right competence. And we can also see that we have one project that is a chatbot where we're using a vendor solution. So we're still contributing with the training data, and we do our own training, but we're using a vendor platform to build this. This is our chatbot, Skatti, if you visited the Swedish Tax Agency's webpage. And we also have examples of where we develop in-house, using image analysis for OCR and HDR. So HDR, handwritten text recognition. We actually just recently, a couple of weeks ago, released a model that helps us to interpret free text information that comes in on the income tax form. So we can actually read this both in a digital form and in handwritten form. So we interpret this in order to direct those cases, direct those texts toward the auditor with the right competence that can help and support the taxpayer with their demands, with their requirements. And this is actually a model that is developed and trained inside Swedish tax. So it's a model for interpreting modern Swedish handwriting. And I think it's one of the few models of its kind currently. We have a few models from other agencies moving towards more historical data. But modern Swedish, I think this might be one of a kind. Okay.
Okay.
Thank you. leaving to you, Jens.
The platform dude.
Yeah.
So I work with the development of our container platform for AI services then. So is that one ready, since we have a number of applications already out in production? And the spoiler alert is, of course, no, no, no. When is a platform ever ready? It's not quite. But we'll talk about what we've done to be able to integrate Java services with ML services with lots of different runtimes. And hopefully we'll end up with a demo. But as Dylan just said, the fun thing about demos is that it not every time works. But well, let's see. I've got my container cluster up here. It might actually work. We'll see that later on. So a number of years ago, I was a senior architect, as we call it then, and I was sent off to a big customer to talk about the toolings they need to create data-driven apps. That was a big buzzword then. I went to that meeting. I've been a Java and Hibernate teacher, doing a bunch of DevOps stuff and creating microservices architectures. And I did some initial Googling. I was a bit worried, but I went to that meeting. And if you are from that company, if you saw me then, just sit down and be quiet, don't say a word, because when I think about this meeting, now many years later on, I'm actually embarrassed, because I didn't quite know then how different the platform must be to be able to develop data-driven applications. And I wasn't even aware that I didn't know it when I went to this meeting. So needless to say, we didn't get the assignment. But now then, to create data-driven applications, what is that? Well, most oftenly you use a technique which is called machine learning. Machine learning is a part of AI, and AI is a part of data science. And the last couple of years, I've spent my time trying to integrate the areas of data science with standard software engineering with the DevOps practices that are now well known to us. And if you manage to combine those, you'll end up with something which nowadays is called MLOps, and that's what I'll talk about today, MLOps. Years have gone by, and now I at least know a couple of things, and it's that the skills you need to develop data-driven applications are widely different from the skills you need for traditional development, regardless of what language we're talking about. Also, the software that you need and the processes in which you work are also widely different. So if you, like us, want to have a platform that should enable writing AI-first applications, that platform needs to be widely different too. So, why does it have to be different? Well, if you look at these familiar circles that you've seen many times, we have a new one here when it comes to MLOps. It's called design. And why do we have that one? Well, it's because when creating applications like this, first you need to really evaluate if your use case is even worth trying to solve using ML. So that's a new aspect of it. That's the first circle you have. The two ones to the right, they might be a bit more familiar. It's about development and operations. But now we're focusing on the word here being model. It's about creating a data science model and then getting that data science model out in production in a streamlined and way that works just like all the DevOps practices we have today. We've done that at Skatteverket. We've productionized 10 to 15 applications, so we have them up and running in our existing container traditional platform. And that's based on Kubernetes. It's OpenShift from Red Hat, and we mostly use it for Java microservices and web apps. So our developers, they write their own continuous integration pipelines, and we force them to use our continuous delivery pipelines then with a bunch of non-functional requirements validation. And after that, we use the GitOps methodologies to deploy these services at various different clusters that we have. We use it a lot, and we like it. But when we looked back at the services that we now have in production, we noted that, really, the actual development of the ML models was all done outside our container platform. And later, we had to kind of shoehorn it into our existing container platform. Now, why is that? Well, many reasons, of course, but our developers, they were now data scientists. And the biggest one being that data scientists usually need access to production data. And at the Swedish Tax agency, we've spent years and decades making sure that developers are separated from our very sensitive production data, both in environments and as individuals. So that was a big thing. Also, all the tools that they need and the runtimes and the languages, it's like Python and R, was earlier unused. And also, to create the models, they really need to use a GPU-enabled server, which was not available in our clusters either. So therefore, they had to do it elsewhere. And I mean, it's fine. When we learn new technologies and start developing things, we must do it in the slimmest possible way we can do. But every once in a while, we need to lift our head up and see in what direction our platform is going. And when we lifted our head, we saw that, so now we have specialized teams working with specialized software on specialized hardware. That means that we have silos, and that's very hard to integrate and scale into an organization that wants to enable many teams to produce AI-first applications then, to actually consider AI first as a solution, and not having to go to a specific team. So that means that we had to do something to our platform. Another challenge is this amoeba, as you see up here. In the very middle, you see a little ML squarish things. It's supposed to show that the actual time data scientists spend creating ML code is actually very little in the whole development process. And they spend much more time doing all these other things like data collection, data verification, turning all these data into so-called features that can be used to training models. And once you have the models, it's a lot of hassle to get them into the serving infrastructure. And the worst part is that it's not even that they spend so little time, as a traditional developer say then, but it's more that these areas are not very well defined at all. It's more like a living organism, and the tools are going in and out into each other. They are constantly changing, and thus also the vendors that makes the tools are also constantly changing. And they are integrating each other's tools, they are integrating open source tools, they are selling products, and they are also going bankruptcy. So it's really hard to be a shopper of ML software these days. Even if you kind of know what you want, there's a lot of decisions to make. You can read more about this in the article MLOps is a mess, but that's to be expected, which I really liked. And lastly, before the technical platform then, no vendor lock-in. We did a bunch of what we called a friction interviews to a large amount of people at the Swedish Tax agency. And we asked them, if we were to do all this, is there anything in particular that worries you when we do this, the enhancement of our development platform? And when we compiled the list afterwards, it came out that their number one worry was that someone was going to buy a big platform and just drop it in somewhere and force everybody to integrate and learn this new platform. Because right now, most people really wanted to learn and explore this new area and work with new tools and kind of get a feel for how we were to proceed with this one. So pretty quickly, our team decided to instead move forward with smaller components, mostly based on open source software instead. So we looked at the process and we thought, so how can we do incremental tool improvements instead? Now, if you are a data scientist, you are likely to start up in the upper left corner of this picture, doing data analysis and model analysis, working with data science experiments. And you will be producing source code in some kind that you put in a source repository, and you will be producing data here called features, actually stored in the feature store. After that, you will trigger a number of pipelines with different configuration and parameters, and you will end up with a long list of candidate models. And that's the middle layer here, automated model training. And lastly, you need to get that model into production. And then we're at the lower right corner, the model registry, get it out, containerize it, and get up some kind of microservice with it. We actually started in the bottom right corner instead, with the simplified model serving, because we thought that it's not really an idea to throw in a bunch of tools so developers can create models if we haven't really cleaned up our backyard and made it real simple to get them out in production. So what I will show you is how we moved forward with the simplified model serving, the initial part. We had a long list of requirements after learning this area. Perhaps most importantly, we want to be able to very simply containerize models of different types. if that is PyTorch models, TensorFlow models, scikit-learn models, H2O Java models. Easy configuration. Also, some should run on GPU, but not everybody. And most importantly, we have so much Java services running out there. So we need to do a layering, which makes it real simple for our Java microservices to interact with the backend ML services, either being written in Python or Java. It doesn't matter. A layering here, that was important for us, so we could reuse all that tooling that integrates with the existing infrastructure. Some more things. We wanted the endpoints to look kind of the same, the protocols to be the same to use, and the ports to be used, so everybody would see a familiar environment when they saw a new microservice. Also, graph of models are very interesting. Sometimes not enough to just throw up one model and create one service. Perhaps you have a graph of many models that need to route different requests coming in and out of, combine the output of it. More advanced areas. And finally, we use Prometheus and Grafana, so we want to interact with those existing login possibilities that we have. One candidate quickly stood out for us when we looked at this, and it was a open source product called Seldon Core Operator. And it didn't only do this, it also did a bunch of other interesting things. But most importantly, it didn't do all these other things that you see, model engineering, data science experiments. It didn't try to cover everything being a big ML platform, only model serving. So that's what we did. Seldon, it's a UK company, and they have this product, Seldon Core, which is an open source product that is actually being used in many other frameworks too, like Kubeflow and H2O, if you've used any of those. And a Kubernetes operator. What is an operator? That's actually a pattern that enables you to customize the behavior of your existing cluster without modifying the code of the cluster itself. What that really means is that you install some kind of a controller, being a daemon service running somewhere in your cluster. In our case, it's a Seldon Core controller, and that controller will watch out and look for new custom resources that we have added to our Kubernetes clusters. And in this case, you see the kind here is Seldon deployments. And once it sees any of those in any namespaces, it tries to pick them up and convert them into standard Kubernetes objects, like deployments, services, ingresses. And it doesn't have to be one deployment. It can be a combination of many deployments. And one deployment may contain many container and pods, of course. So it takes care of understanding how you translate a model into a REST service, if that's what you want. So that's what I would like to show. Let's see, where am I? Well, let's see if my cluster is up and running now then. Perhaps it is. I had to restart it just seconds before this presentation. Yes, remember that password. Hallelujah. No, don't do that then. Never mind. Okay, so that is working. That's good. We might have a demo here. So what we will show you is how actually to install the Seldon Core operator into any cluster. Hopefully, I hadn't tested this. I've only tested it in OpenShift, but we have used not OpenShift specific commands at least. And after that, we will install 2 microservices in 2 different ways, and then we will install another client service written in Java that will access these 2 services that we have. To get an idea how it actually would work if you were to improve the model serving part of your Kubernetes application. So this code is also accessible on GitHub, so you can go to, you'll also find a link by the end, and you can, most parameters have also been adjustable, so you can, if you want to tune them and use them on your own clusters, hopefully, and just send me a pull request for an improvement if you want to. So, first part, installing the operator into our cluster. There are many different ways to do this, depending of your Kubernetes technology you use. In OpenShift, there's something called Operator Hub, which can be used. And that also has a GUI, which is might be nice too. And you can use that for kind of practicing Seldon Core Operator. But in our case, we needed to do a bunch of customization. So instead, we went with the option of using Helm to install it. And why did we do that? What's important for us when we install our operator? Well, so Celdon, they provide a Helm chart that you can use, and it has these standard alterations that you can do. Of course, where should it be installed? Where does the software come from? What version do you use? But more interestingly are these other ones, because the rest of these ones, they adapt how Celdon Core Operator should transform the Celdon deployments into standard Kubernetes deployments once they appear on the cluster. And there are a number of those, and I'll talk about a couple of them so you kind of understand where I'm going here. First of all, Celdon Core can automatically expose all your machine learning services onto your cluster, and they do that by integrating with a number of service meshes like Istio or Ambassador. Now, we didn't want to install any service mesh into our infrastructure, and we also didn't want to expose all our microservices into any namespace, because we always create wrapper microservices, usually in Java or some other language, integrating with our own infrastructure. So we turned that off. Also, the user ID can be anything when you execute all these containers that will pop up. But in OpenShift, we would like OpenShift to instead inject the actual user ID, because we want all the containers to run in an unprivileged environment. So we deleted all the user IDs of the installation to allow OpenShift to do this. Also, we are not allowed to run any software coming from outside our networks. So we had to adopt all the repository paths that we use. So instead, we had to create local repositories into our Artifactory instance, and we had to make sure that whenever Celdon installs a new microservice, it has to fetch all the images from our internal Artifactory instead. So there are a number of paths like that. And finally, we already use Prometheus to scrape logs, so we also adopted that path, of course, to have all the services using the same paths. So if we run this then, let's see. Well, at least something is created then. So now we will see two projects here. It's the same as namespaces in standard Kubernetes being popped up. This one is called the Celdon system, and that one should have the controller installed now as a workload. Oh, hey. Yes, it's popping up now, so it will take some time since I had to restart my whole cluster and delete everything. So perhaps we'll see if it actually starts up in time. So now we have this daemon service up and running in my local cluster, waiting for Celdon deployments. And the two Celdon deployments that we would like to ship to this cluster, well, now it's up and running, by the way. Dark blue. Great, great. This is going great. First of all, we want to do a kubectl apply for a new kind of a custom resource. That's the Celdon deployment. And in this first case, it kind of looks similar to a standard Kubernetes deployment. But here you see instead a model URI implicating that what we will do now is that we will have Celdon create a microservice by actually downloading a physical binary model being in some object storage. And there are a number of object storage that you can use. In our case, we'll use a S3 compatible storage. And for demo purposes, this S3 compatible storage is Google now. We also need to tell Celdon Core Operator what type of model this is, so it knows what runtimes it should provide for it. So therefore, we tell it that this is a scikit-learn server that you should use to deploy this microservice. That's the first ML service. And let's ship off that one. Run. No, wrong button. And we'll while that one is starting up, we'll move on to the third one. We've deployed the model artifacts, and what we'll have then will be a very simple graph just containing one model wrapped in some reusable server. And Seldon Core will also provide an interface for it, make sure the ports are up and the protocols that you want to use are being used. That's the first one. The second one is slightly different, fairly similar, but when you look at the actual Seldon deployment that we will apply now, we instead see a, let's see here. Our Seldon deployment now doesn't have a URI. Instead, it has a reference to an image. And why is that? Well, it's because in our organization, we don't really know what a model artifact is. We have a bunch of infrastructure that is used to deploying new versions of Docker images. And we have teams knowing how to produce new versions of Docker images. So if we were to say that you have to start producing new versions of model artifacts, we would have to do a bunch of changes to our whole infrastructure. So instead, we wrap up our models into a microservice first in our continuous delivery pipelines. And then instead, we simply deploy that image instead. So that's just an image reference then. And in this case, you'll see it up here. Once we deploy it, what that one is, it's an scikit-learn iris image we'll go with. So that's the third one, being the serve. So now, we should have in our other namespace, being called a Seldon project, we should have 2 workloads on their way up. Well, they're still downloading, so none is ready yet there. So you might ask, this image, how do we do to produce it? And we won't have time to show that today, but usually in OpenShift environments, you use a feature which is called source to image, giving you the possibility to turn any kind of source code repository into a Docker image. Now, we do that, but also Seldon Core provides a specific S2I image, allowing us to do this much more simply. And as you can see here, we just use an additional environment file where we point out that this source repository will have a, in this case, Python class, could be a Java class, but named served model. You should expose that as a REST service, and this image is of a type model. It will be a predictor service. And that is how our Python class looks like. It should have a couple of specific signatures, a predict method and an init method. And in that init method, we simply load the models that we provided. And we actually did an extension of the Seldon Core S2I installer in which we enabled to just add another environment variable for the URI to that model. So we download it from our Artifactory instances and then create a new image and ship that image back to our Artifactory. But it takes too long. We won't show that now. We need a client to test if this works, and I will try to deploy it immediately. Run. The Java client. And while that one is being deployed, I will just first give a couple of more notes. Now, in this namespace, what you see here are the 3 standard Kubernetes deployments down here. But what you don't see is also interesting, and it's that in this namespace there are also some other new YAML files, because we have more resources now. Let's see, let's do a search for deployment. Can I run? Do I dare to? Yeah, I dared. We have something. We have these Seldon deployments, although we don't see them, and we have these deployments that were created. So in this namespace, we now have 2 Seldon deployments, and those have been transformed by Seldon Core Controller into 2 deployments, and then we have the standard Seldon Java client also. Let's see if it's. We can actually look into this deployment too, just to learn a couple of things here. It's that one deployment can involve many containers, and in this case, you will see at first we use this image that we built, that someone else built really. It's called the scikit-learn Iris 0.3 version 1. That one is wrapped into a container here, but also Seldon injected another container which will take care of all the API calls, the metrics, the feedback if you have that, the logging, and the interaction if it's a full graph that we're deploying. Because you can actually deploy graphs that are kind of more like this. And you see in the bottom end here, well, you'd hardly see it perhaps, but in this case, we've shown how a complex Seldon core inference graph can look like. And this one involves actually 7 images and thus 7 containers instead, involving 3 models being wrapped in containers, and then having a router selecting in runtime which model should be used. You can also use a combiner to combine the output if you have several containers. You can do feature transformations before, or pretty much anything that you would like to do. Detect outliers or provide some kind of explanation to the answer you are giving. So that's called complex graphs, which will create also complex deployments. Also, this Java client that we deployed, let's see the source code for that one, for the deployment at least. Well, we can first look at the actual service that we are deploying. It's just a standard vanilla REST service using Jakarta EE micro profile. So probably very familiar to you. We have 2 paths here. The model path, which will simply do a forward, invoke a post prediction request to the Seldon model default service, which is the wrapper service for the first service we deployed. And we have another one for the second one here. If we do a get request to the /image path, it will simply do a post prediction to the Seldon image default service. And that's also a really, really simple, just a post of some test data to this very similar API then. All services that Seldon create will have very similar interfaces. HTTP in this case, port 8000 API, blah, 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 blah. And in order to actually see anything of it, of this standard deployment that we create, so the deployment just looked like this. Deployment object, no Seldon deployment, referencing this image that we could have built but didn't build. It was just a standard Docker build. Nothing particular about that one. No S2I. We added a service to expose these new paths, and also a ingress to be able to access it from the browser, from the outside. And if it's up and running, projects, Seldon projects, workloads, nice picture. This is the client one. It's very hard to see. Sorry about that. But we also have a route. So if we click that one, we arrive at our route path where we have nothing. And let's adopt this one then to see the result of it. We have a system war file in here and prediction path, and then we start up with the model one, which was one of them. And if you do that, it will forward the get request as a post request to the backend ML service. And you see that it ships some additional meta parameters also, showing you that it's a scikit-learn server serving this request. And you can add all kinds of customize feedback here already. The second one is just this one, the image path then, looking very similar. So now we have 2 ML services up and running, written in Python, and we have a Java client access it all from within the same namespace, and nothing is exposed except that very Java service that we wanted to expose. And it's in this Java service that we add all the code for integrating with the infrastructure, the Oracle databases, our message brokers, and all that. So that means that we also can deploy only the machine learning service on a node that requires GPU. We don't have to deploy our Java services on nodes that require GPU. Yeah, that's it for the demo. If you want to, you can check out the source code and try this tonight if you want to. Meanwhile, we are now installing all this into our microservices cluster. It's what you see here on the bottom right part of it then. So the Seldon is being installed and enabling us to deploy microservices just like I've shown you. But meanwhile, we're also figuring out all the other tools that we need to go forward. But we realized that we don't want to do this in the same cluster that uses online prediction services. Because that could actually affect, then we would have development actually affecting production environments. So instead, we acquired a separate training clusters, as you see there, the top left part of it. And this is where we now are evaluating a bunch of tools enabled to create our first version of the complete data science platforms for the Swedish Tax Authority. And we have a couple of candidates. We're not quite sure that we're going all the way with all these tools. We've used something called the MLOps Stack Canvas. It's a method you can use in order to figure out the minimal list of products that you really need to get this software up and running, doing what you want in your own clusters instead. Because there are so much possibilities, you need to have some clever processes or figure out what really you want to do. So check that out at mlops.org, and hopefully we can come back last year and tell you about the perfect platform that we have up and running. Or not, we'll see what happens. So that's what we have to show today. Thanks for viewing. We're really happy to talk with anyone and everyone who has experiences of similar strategies and implementations of data science platforms. And you can scan this URL if you want to check out the repository too. And yeah, I'm on the technical bottom part of it, and Andreas is the one who's trying to produce data-driven applications. So
getting something done, yeah.
So are we ready, Andreas?
Well, I think we are on a good path.
Yeah.
And I think that what makes Swedish Tax unique is actually that we are, as Jens was saying earlier on as well, we are getting things out to production. We're not staying in a pilot or a proof of concept. We are actually having a number of applications up and running all the way out in production. And I think that makes us unique. But I think that, are we on the right path? Yes. Are we all the way?
No, not quite.
I'll leave that to the audience to decide actually, but I think on a good path for sure.
So thank you for listening. Does anyone have any questions right now? Yes?
Yeah.
It was very interesting. You wrote that you take an AI-first approach to things, and I think that's kind of strange because sometimes I hear that like AI should be like just a backup plan or the last resort if you really need AI. So I'm curious, do you feel like you're kind of causing a danger of applying AI to use cases, or especially in the predictive space, especially in taxes?
Yeah. So the question being that is there a danger of using AI first strategy? As we said before, AI first, as we stated in our AI policy, is more to challenge ourselves, to think about AI first. We are not applying AI to every case we can apply AI to, because that, I agree, that could be or is even a danger, because you might end up losing or choosing the wrong path, or adding a lot of resources not needed actually to solve the problem. So what we want to do with the AI first in our policy is actually to challenge ourselves to see if AI is a better solution. Is it a better solution than the standard way of coding things? Can it bring something new to the table? Can we solve it in in a better fashion? Can we solve the problem more efficient? Can we decrease the maintenance of things, etc., etc.? So what we want to do is challenge ourselves to think AI first, to try AI, to analyze if it's a better solution, and then choose. So thanks. And I think that that's it for us. If you have any more questions, please come back down to me, Jens, after the presentation. And yeah, thanks a lot for the attention.
Yeah. Thank you.